Hey everyone, Mr. Skelton here. We're back at it for lesson 6 in unit 1, and today we're really going to focus on two concepts that you've probably heard before. The first one being finding the perimeter of objects and finding the area of objects, rectangles. Really we're going to focus on rectangles, and then we have a couple composite figures towards the end. So our learn target check today is I can find the perimeter and area of composite figures. All right, composite figures, if you're just not wondering what that is, composite figures at the back, and we'll get to it, they look like this, where you have more than one kind of rectangle or square, kind of making one big giant figure. So we'll get to that in a minute. I would imagine a lot of this stuff would be review for you here in the beginning, but I want to make sure we go over it and take our time, and if you have questions that I can follow up with you when I see you in class. But essentially, perimeter is the distance around a shape, okay? It is one-dimensional. Therefore, we use the label, we just call it units. So, you know, you could have centimeters, you could have inches, you could have feet, you could have millimeters, right? We don't square those. There's just centimeters, feet, inches, depending on what unit it is. We just find them in units. Again, perimeter would be something like this. If you had a rectangle, and this was 4 and this was 3, okay, then it would be 4 and 3 here. Perimeter would just be adding up all of those sides. 4 plus 3 plus 4 plus 3, 7 and 7. The perimeter would be 14. That's a quick example of perimeter. Area, most of you know area. You've heard it before, but you may have forgotten what area is. Area is how much space a shape occupies. Okay, occupies. It's two-dimensional, and therefore we use units squared, right? So we use like inches squared, feet squared, centimeters squared, because we're taking length times width, or base times height if we're doing a rectangle, all right? And I'll do a quick example of this. So I'll use those same numbers, 4 and 3, and let's say this was feet and this was feet. So if we wanted to do the area, which is length times width here, we could do 4 times 3, which is 12. And a lot of students will, well, where does inches or feet squared come into play? Well, 4 times 3 is 12. Feet times feet gives you the feet squared, and that's why area is units squared. So really the area formula that we're going to focus on in the perimeter formula for rectangles, I've kind of already talked about it here. You see this quite often with rectangles, 2 times L, so 2 lengths plus 2 widths, right? 2 of the lengths, so there's your 4 and 4, and 2 of your widths, 3 and 3, and then area is just length times width, okay? So those are your formulas that you'll need, and most of you know that. Now, on this first example here, you may want your calculator. It says find the perimeter and area of a rectangle with a base of 5 feet and a height of 54 inches. So you get something like this, okay? You're going to have to convert one of these inches to feet. I'll kind of do both for you so you can kind of see it, right? If I have 5 feet, how do you turn that into inches? Well, how many inches are in 1 foot? There's 12 inches in a foot, so 5 times 12 should give you 60. So really this is 60 inches here by 54 inches here. So if I wanted to find the perimeter, I would go 2 times 60 plus 2 times 54. And so you get 120. 120 plus 54 is 108. 108. So you get 228. So you would have 228 inches, okay? If you wanted to turn that into feet, you could divide that by 12, right? Because there is 12 inches in a foot, and that would give you 19 feet. So you have answer of 19 feet and then 228 inches. Those are the same. I just went from inches to feet. If you're talking area, again, area would be length times width. So I would go 60 times 54, and I go 60 times the 54, which gives me 3,240 inches, okay, squared. That would be my answer in inches for the area. Okay, I'll put the arrow here. Now, a lot of students will make a mistake on this one. Over here, because this is just regular inches, I can divide just by 12, because remember, this is one-dimensional. But this is 3,240 inches squared. If I want to turn that into feet, you can't divide by just 12, you have to divide by what? You have to divide by 24, okay? Or excuse me, not 24, but 144. And the way I get the 144 is you have 12 and 12, one for the length, one for the width. So you would take that and divide by 144, and that would give you 22.5 for the area, and that would be feet squared. So basically 22 and a half. Okay. Let's take a look at another example. This is somewhere where you have to do some figuring out. A pool has dimensions that are 15 feet by 20. So if you can't read this, this is your pool here. All right, 15 by 20. The pool has a deck surrounding it that is 3 feet wide. How much would it cost to build a fence around the area, this area, if fencing is $12 per foot? Okay, so if it's 3 feet around, then this is 3 feet here to here, and this is 3 feet. So what's this total distance? Well, you have 15 from here to here, plus 3 plus 3. So that's going to give you 21 for that entire length. Okay, and you have to do that vertically as well, right? This is 20 feet from this point of the pool to this point of the pool, but we have to add 3 feet that way and 3 feet that way, so it's really 20 plus 3, which is 26. So if I got to figure out how much fencing I need to go all the way around the pool and the cement deck, I'm going to do perimeter, because fencing is putting up fencing all around, so that's perimeter. So I'm going to go perimeter equals 2 times 26 plus 2 times 21. So 2 times 26 would be 52, plus 2 times 21, which would be 42, and 52 and 42 is going to give you 94. Okay, so you should have 94 feet. Now the directions say, how much would it cost to build a fence around this area if the fencing is $12 per foot? So I'm going to times that by 12. So 94 times 12 gives you $1,128. That's how much it would cost to fence if your deck and pool 94 feet. Now, this one says, how much did the concrete deck cost if the concrete cost $2.50 per square foot? All right, this is a little trickier question. So what you got to do is figure out how much concrete you used. Well, let's take a look at this. If I find I'm going to do a little subtraction here. The area of the entire figure is going to be 21 times 26, right? 21 times 26. But I'm going to subtract from that the area of the pool. Obviously, I'm not putting cement in my pool. I want to figure out what the area of just the cement is, the square footage of that. So I got to find the area. So the area of the pool is going to be 20 times 15, right? 15 by 20 is the pool. So 21 times 26 gives me 546, and that's feet squared. And I'm going to subtract from that the area of the pool, which is 20 times 15. That gives me 300 feet squared. And when I subtract those two, I should just be left with 246 feet squared that I used to, I'm off the page, sorry, 246 feet squared of cement. So I want to times that by $2.50 per square foot. So 246, I'm going to times that by 250, and that gives me $615 worth of cement. Okay? On the back side, these are your composite figures here. So you've probably had some experience with this. It says find the perimeter and area of each composite figure. So what I like to do is try to figure out where my missing units are. So for example, like if I wanted to find this distance here, well, I just always go to the opposite side. If I'm talking length here, then look at this length, that's 10. Well, if this is 6 and the whole from top to bottom is 10, that means from the top to bottom here has to be 10. So 6, which means this has to be 4, right? This has 6 plus 4 has to make 10. Likewise here, I don't know what this distance is across the top, but I know the whole bottom distance is 15, and I know this part here is 4, so 15 minus 4 should give you 11. And just double check. 11 and 4 should make 15. So now I can find the perimeter. Take my calculator out and just go around. 10 plus 15 plus 4 plus 4 plus 6 plus 11. That gives you 50 meters. Now if you want to find the area I usually close off and make some shapes, different shapes. So like this now becomes a square. 4 by 4 is 16. So that's the area, that's meters squared. And then this would be 11 by 10. So 10 times 11 would give me 110 meters squared. And then I just add those together. So add my 16 to it and I get 126 meters squared. Okay? So why don't you go ahead and hit pause and try this one on the bottom on your own and see if you can come up with the right answer. This one's a little bit challenging, but you can give it a shot here. Okay, let's take a look. So I know that this distance from here to here is 6. So you have 3 and 3. You know this is 3, so you know this has to be 3. I kind of go around and fill everything in that I need to know. I got to find this distance right here. I know this whole thing is 10. So there's 3, 6, 8. So that means I got 8, so that's got to be a 2 there. I think I have all my sides covered now. So let's find the perimeter. I'm going to start at this 10 and work myself around. Let's see, I have that. I just double check. I got that side, yes, yes, that side, top, side, top, side, top, side. Okay. 10 plus 3 plus 3 plus 6 plus 3 on top plus 3 there plus 2 plus 3 plus 2 plus 3. And I got 38. Okay? I'll double check it going around the other way. 3 and 2 is 5. 3 and 2 is 5. That's 10. 3 and 3 is 16. 16 and 6 is 22. 22 and 3 is 25. That's 28. And 10 is 38. Good. Okay, area. Now, let's do, you can do this a lot of different ways. I'm going to draw this like that. I'm going to close this one off here. And I'm going to go from there. So this bottom rectangle here is going to be 10 by 3. So that's 30 centimeters squared. This is 3 by, let's see, what is this length going to be right here? Well, that's 2 and that's 3, so that's going to make that 6. So 3 times 6 is 18 centimeters squared, right? 3 times 6. This distance right here, that's a 3 and that's a 3, so that's going to be 3 times 3, which is 9 centimeters. So I'm just going to add all these up, and that should give me my answer. So 30 plus 18 plus 9 gives me 57 centimeters squared. And again, you could have drawn vertically lines and made it a bunch of squares if you wanted to do that. So there's a lot of different ways you can do composite figures in terms of creating or drawing in the lines that you want. All right? If you have any questions, we'll talk about it in class.